Hello students. So today we are going to learn about permutations. Okay. So what is a permutation? Permutation is an arrangement in a definite order of a number of objects taken some or all at a time. Okay. And number of permutations of n different objects taken r at a time. Okay, is given by NPR, that is n factorial upon n minus r factorial. Okay, so here basically if you take say a word, okay, for example number, okay, and I want to find out number of possible ways a three-letter word can be formed using the letters of this word. Okay, so total number of letters are, that is our n, 6, correct, and I want to write three-letter word from this letters, so our r becomes 3. So now we have to find the permutation of this. Okay, so in this case the repetition is not allowed. Okay, that is you can't use n like this. Okay, so all three letters should be different. Okay, so this becomes our 6 factorial upon 6 minus 3 factorial, that is 6 factorial upon 3 factorial. So we can write this as 6 into 5 into 4 into 3 factorial upon 3 factorial. So 6 into 5 into 4. Okay, and this is actually related to multiplication principle. Okay, same as multiplication principle, because if you want, these are the number of letters you have and you want to write a 3-letter word without repetition. Okay, then you'll have the choice for this will be 6, this will be 5, and this will be 4, right? And then you have to multiply them, that is using multiplication principle. And if the repetition is allowed, then it will be 6 into 6 into 6. Okay, so that will be what? 6 factorial 6p6. Okay, that is 6 factorial upon 6 minus 6 factorial, which is 0 factorial. 0 factorial is 1. Okay, I'll write here 6 factorial upon 6 minus 6 factorial. So 6 factorial upon 1. So 6 factorial. 6 into 5 into 4 into 3 into 2 into 1. Okay. Let's see when the permutation, when all the objects are not distinct objects. Okay. That is, they have taken one example here. Rearranging the letters of the word institute. Okay. Now here we have I 2 times and T 3 times, right? So they are repeated. So here the permutation will be what? You have to take the total number 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Total number upon I is 2 times, so 2 factorial, and T is 3 times, 3 factorial. Okay, so this is the theorem. There is a theorem. The number of permutations of n objects where p objects are of the same kind and rest are all different. Then it becomes n factorial upon p factorial. Okay. One more example. Find a number of permutations of the letters of the word Allahabad. Okay. A L L A H A, B, A, D. So now we have to count. A is 4 times, right? And L is 2 times. Total number of words is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be 9 factorial upon A is 4 times and L is 2 times. So we can expand this, that is 9 into 8 into 7 into 6 into 5, and then 4 factorial, then 4 gets cancelled, then 2 also you can cancel. Okay, that is easy. Next example is how many 4-digit numbers can be formed by using the digits 1 to 9 if repetition of digits is not allowed. Okay, so if the repetition of digits is not allowed, then you have to use this formula NPR. Okay, so total number of digits which are available are 1 to 9 they have. So n is 9. Okay, and we have to form a 4-digit number, so our R becomes 4. So the permutation is 9p4, 9 factorial upon 9 minus 4 factorial. So this is 9 factorial upon 5 factorial. 9 factorial is 9 into 8 into 7 into 6 into 5 factorial. So 9 into 7 into 6, that is 3024. Okay. Next question. These questions are from the textbook. Okay. How many numbers lying between 100 and 1000 can be formed with the digits 0, 1, 2, 3, 4, 5 if the repetition of the digits are not allowed? Okay. How many numbers lying between 100 and 1000? Okay. So from 100 to 1000 between, so starting from 101 and ending at 999, so these are 3-digit numbers. Okay, and the repetition of the digits is not allowed. So 101 11 is not allowed. Okay, so we have to take, and the number of digits which are given are 0, 1, 2, 3, 4 and 5. Okay, so 6 digits are available and we have to make use of 3 digits. So repetition is not allowed, so here we have to make use of NPR. So this will be 6p 3. Okay, but here there is one twist. Okay, so when you are writing 3-digit number, okay, that number can be of the form, since these digits are there, the first digit can be 0, right? Then 1, 2, like this. But this number is not between 100 and 1000. So we have to remove this type of numbers. So we'll take another permutation in which this number is fixed at the 100th place and we have to change these two numbers. So if this is fixed, then we have 5 choices, correct? And we have to change 2 numbers. So the permutation of this will be 5p2. And this type of numbers we have to remove from this numbers 6p3. Okay, so total permutation will be what? 6p3 minus 5p2. Okay, so this will be 6 factorial upon 6 minus 3, that is 3 factorial, minus 5 factorial upon 5 minus 2, that is 3 factorial. So 3 factorial gets cancelled. You will get 6 into 7 into 5 into 4. Oh, sorry, 6 into 5 into 4. And here it will be 5 into 4. 5 into 4, you can right outside. 5. So this is 100. Okay.